Hi, welcome to MACSGATE. We are learning DBMS subject. Under DBMS subject, we have started SQL, Structured Query Language. In the last session, we have seen the basics of SQL and especially DDL, Data Definition Language commands, which mainly deals with the structure of the relation. And in this session, we are going to discuss Data Retrieval Language. Data Retrieval Language, in which we mainly concentrate on select command. How to extract the data depends on our requirement from a given relation. In this, we don't modify or we don't update any data in the relation. Just we retrieve the information what we need. So let us start the session. Data Retrieval Language. The main command or one and only command is select. I want to select the information from a relation. Then what information you want? First of all, let us see what is the general form of a select. Select. Here we write the attribute list or the columns list. Column or columns. So what are the columns or what are the properties of the records we want? From select the attributes from which table. So the table name. From which relation you want the information. Either the information may be related from one table or two tables or three tables. So what are the properties we need and from which table we need to retrieve. Then for which records you want that particular information. So here we write the conditions to select the particular records. Conditions. Why we need to impose these conditions, sir? Mainly to filter the records or to select our particular records. Okay. This is the general form or basic form. In basic form, we have mainly these three, sir. Select the attribute list from the table list where we are having. In addition to this, sometimes we may need to use group by. I want to get the details of the properties, group by some attribute. So here we need to write attribute list. Suppose I want pass percentage of so and so college, group by departments. So on which basis you want to group the records. After making groups, sometimes you may filter some groups. You may filter some groups. So conditions to filter some groups. To filter the groups. Fine. So this is the main one, sir. After we got the particular information, whatever we need, then we may need to order the records. That is, I may need to display the records order by rule number, order by percentage, or order by name. Like that, we need to order by the attribute list. The attribute list. Whether you want ascending order or descending order. Ascending order is default, sir. If you want to display the records in descending order, then we need to specify DESC. Hope you understood it. This is the main one, sir. Among these, the first two are mandatory, sir. The first two are mandatory to write a DRL query, because compulsorily I need to select some attributes from so and so table. All the remaining four are optional. That depends on our requirement. Sometimes we may not need these four. Sometimes we may need it. But this is the main one, sir. In our GATE exam point of view, they mainly concentrate on select command only. So we are giving more preference to the select command. And in the upcoming examples, we will discuss different possible questions and how to use all these keywords. Okay. So let us start the examples. If you have any doubts, please raise in chat box. Fine. Suppose we have a relation whose name is student. We have a relation whose, this is my relation student, in which I have three attributes: student ID, SID, name, the student name, age, the age of the student. Let us assume for few examples, this is our relation and we need some particular information from this relation. So let us discuss different possible questions on this relation. I want to list out all the details. So the first point is we need to identify what are the attributes you want. Do you need all the properties or all the attributes? This is the main one. First we need to identify, because we need to specify this list in our select, right? Then what is the table name? Okay, and they are asking about students, right? So the table name. The next one is, does they need the details of any particular students? No, sir. They need the details of all the students. So the answer will be select. I want all the attributes. Whenever you need all the attributes, you can simply write star. Select star. What does it mean, sir? It is for all attributes. Star means all attributes. From which table? That is the second one. From which table you want, sir? The table name, here it is student. The table name, here it is student. Now, do you need any specific students? No, sir. I need all the students. So we are not filtering the records. Whenever you don't filter the records, no need to specify this where. So this is the one and only answer for this question. Select star from student. Hope you understood it. Let's go to the next example. Now look at this, sir. Here we need the names. List the names. So I need only the names. This is the first one. And I need all the students. No need to specify anywhere. So no need of where clause. Right? So let us start it. Select. I need the names. What is the attribute name for names? What is the attribute name for names? That is name. We need to specify the attribute name, because I need only the names. Then the question is, from which table you want, sir? From, what is the table name? Student. Do you have any condition on the students records? No, sir. I need the names of all students. Since all students, we don't write where clause, because we are not filtering the records of the table. Hope you understood it. Let us go to the next one. List names, comma, ages. So I need two attributes. About how many students? All students. So these are the 2 points. The first one is select. What you want to select, sir? You want to select 2 attributes. What are the names? The first one is name, sir. So you need to write name, the attribute name, comma. What is the second one, sir? Age. The attribute name is age. Suppose if they need some more attributes, we will list out it. Then from which relation, sir? From, what is the relation name? Student. We are not filtering the records of the student. So no need to specify the where class. The next one, list out all the students. Sir, it is all. So it will be star. Then list out all details of all students. But now I have a condition to filter the records. I don't want all the students, sir. I want only the students whose age is greater than 33. So I need the first record, I need the third record, and I need the last record. Right? So we need only 3 records, but I need all the details. Right? The first one is select. You are selecting. Fine. What you need, sir? All attributes. Select star because you need all attributes. Right, sir? Then from which table you want, sir? From student. Now we don't need all the students. We need only the students whose value in age is greater than 33. So I need to specify the where class. Where, what is the condition they given, sir? The condition they given is age must be greater than 33. Please check it, sir. So we need all the details for the students whose age is greater than 33. The next one, same question, sir. List out all the students from the student table. The only difference is now the condition I have equality. That's it. I have equality condition. In the previous example, we have greater than condition. Hope you can write it on your own. Select star from student where age equal to 40. So this is the way to filter the records. Now let's go to the next one. List out IDs comma names. Now I need only 2 attributes, only ID comma names of the students whose age equal to 40. The same story, but now I don't need all the values or all the attributes of the records. I need only 2 details of the records. So select, what is the list you want, sir? IDs, that is SID, because the name here it is SID. The next one is name, SID comma name. From which table, sir? Student, right? Where, what is the condition, sir? Age equal to 40. Okay. Now and or not. Generally, these are the logical operators. If you are having familiarity with C language, these are the logical operators. Generally, where we use these logical operators are to combine two or more conditions. To combine two or more conditions. In the previous example, we have only condition on age. Sometimes I may have condition on name also, or I may have a condition on department also. Like that, whenever I have two or more conditions, I need logical operators. I need logical operators to combine those conditions. Hope you know the meaning. C1 and C2. My intention is this is condition 1 and this is condition 2. So it will filter or it will select the records for which condition 1 is true as well as condition 2 is also true. Both must happen, sir. And no need to use any symbol. This is the keyword you can use directly. We don't specify any symbol, sir. Directly you can use keyword. We will see some examples, sir. Fine. So hope you know what is AND symbol. Whenever both conditions are true, then only it will give the result. That is the first one, AND. The second one, C1 or C2. What does it mean of or, sir? Either the first one is true or the second one is true or both are true. So even the first condition is true and second condition is false, no issue. The first condition is false, the second condition is true, no issue. Both are true, full happy. Both are false, no happy. Right? So that is about the two. What about the third one, sir? Not. The simple example is, suppose in the previous example we written age equal to 40. Now I don't want the people whose age equal to 40. What does it mean, sir? In general mathematics notation, the people will write like this, age not equal to 40. But we don't have any symbol like this in SQL. So in such case, what we do is, we specify like this, not of age equal to 40. So it will give the records for which age is not equal to 40. Hope you understood the meaning of these logical operators. So mainly they will be used in where clause whenever you want to filter the records based on two or more conditions. Let us see some examples based on this. List out all the details, fine, of the students. Of course, for some more examples, the table is same, sir. Whose age not equal to 40. How you can write, sir? Select, I need all the details. From which tables are? Student. Where, what is the condition? Not equality. So what we do is, we write first equality, then before that we add not. Hope you understood it. So it will give the records for which the value is not equal to 40. So this will not be displayed, this will be displayed, this will not be displayed, this will be fine, this will be fine, this will be fine. So these are the records which will be displayed for this query. The next one, list out all the details star of the students whose age is 40. Condition 1, and this is our keyword, ID is 33. So this is condition 2. select. What are the columns we want? We want all the details. So it is star. From which table? Student. For what records? In where clause we specify it. What is the first condition? Age equal to 40. And we write the keyword and. What is the second condition? ID. What is the name for this one, sir? SID equal to 33. Hope you understood it. The next one. List out all the students of all the, list out all the details of all the students whose age is 40. C1. That is condition 1. Or the second condition is 55. Either the first condition is true or the second condition is true. That means the first condition is true, sir. It will be displayed. Then the first condition is not true, sir. What about second condition? C2. It is not true. It will not be displayed. First condition is true. Whenever the first condition is true, we don't verify the second condition, sir. First condition false. Second condition false. First condition false. Second condition true, sir. So it will be displayed. The same you can do the remaining. So how to write it, sir? Select. I need all the details from, what is the table name? Student. For which records? Where the condition 1 is age equal to 40, or what is the second condition? The second condition is on SID, that is equal to 55. Not only two conditions, sir. We may have so many number of conditions based on the requirement. Let us go to the next one. Between. When we use this between, suppose I want the records between a particular range. Okay. For example, list out all the students, list out all the details of all the students whose age is from 30 to 40. From 30 to 40. So, if I don't want to use between, select star from student. Sir, what is the meaning of 30 to 40, sir? It must be greater than or equal to 30. And it must be less than or equal to 40, because I need only the students whose range is in between these two. So this is my condition 1, this is my condition 2. So if I don't want to use between keyword, directly I can specify like this, where age greater than or equal to 30 and age less than or equal to 40. Okay. So here we not specified between. Instead of this one, you can use the between keyword whenever we need the records between a particular range. Select star from student where age between Okay, let me write in where age between, what is the range number, sir? 30 and 40. So where age between 30 and 40. The next example, list out all the details of students whose name starts with S. So till now we mainly concentrated in all the previous example, we mainly concentrated on numerical examples. Numerical attributes. Whenever it is numerical attribute, generally you can have age equal to some number, age greater than, age less than, greater than or equal to, less than or equal to. These are the possible relational operators. Suppose I have name, it is a string, sir. Whenever I have conditions on strings, if you know the exact string, you can use surely equality, sir. But if I know only some pattern or I know some partial data, then how to deal with them? So let us start it. List out all the details of all the students whose name starts with S. So I don't know anything about names, but the first letter is S. 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 That's it. So I need 22, 11, Shyam. How to write it? Select. You need all the details. Yes. From student. Up to here it is common, sir. Where? What is the name, sir? Name is name only. Where name like. Sir, like is a keyword, sir. Whenever we are dealing with conditions on string attributes, like is very good one we can use in the conditions. So where name like, I know only the first letter S, the remaining I don't know. For them I need to use percentage symbol. S percentage, what does it mean? S followed by any sequence. S followed by any sequence. That is the meaning of it, sir. So here it will be S followed by any sequence or string. But the first letter must be S. Percentage, any string. Okay. Let us go to the next one. List out all the details of all the students whose name starts with RA. Sir, previously they given one letter, now you are having two letters. I know the first two letters, RA. I think in this case we will get only the last record, that is Ravi. So the same story, sir. Select star from student where name like the first two letters R A followed by any string. Not only one character or two characters, you can specify even 10 character also, because I know the information about the first 10 characters. That is the meaning of it. So RA followed by any string. The next one, list out all the details of all the students whose name ends with M. Now I don't know the starting letters. I know the ending letter, that is M. M. So I think Ram will be displayed, Sham will be displayed because the last character is M. So these are the two records we get for this question. So the same story, sir. The first two, there is no change. Select star from student. Where clause is main one, sir, because it is used to filter the records what we need. So where, what is it, sir? Name. Where name like, now I don't know the starting character. Any string followed by M. Any string followed by M. Because I know the last character. So it can be any string, but the last character is M. Any string followed by M. Hope you understood it. The next one, list out all the details of all the students whose name starts with S. I know the first character, ends with A. I know the last character also. So first character is S, last character is A. I think Sudha will be displayed. First character is S, the last character is A. First character is S, it's not. First character is S, the last character, it's not. And I think the remaining also will not be displayed, right? So we can do it, sir. Select star from student, where we have a condition on name attribute. Name like, now I know the first character. I know the first character. I know the last character. In between, it may be any string. First character, last character, in between any string. Hope it is clear, sir. So strings starting with a particular set of characters, strings ending with a particular set of characters, strings with starting letter and ending letter. Now suppose, look at this, list out all the details of the students whose name contains the pattern. Sir, I don't know whether it is a starting character or whether it is a ending character. I am not sure. But surely the name contains AV. AV. I think it was not there. It was not there. Yes, we have here AV. So Ravi will be displayed. Then how to specify it? Select star from student, where name like percentage AV percentage. Sir, any string AV, any string followed by AV followed by any string. Sir, even it may be null string also. Sir, percentage, this meaning is any string. In any string sets, we have null string also. Can be null string also. For example, we have a record Avinash. Then AV, it was not preceded by anyone. It was followed by INSH. So the first one is empty, the last one is INASH. So that is a story about the conditions on string attributes. The next one, list out the names of all students whose name contains Exactly 3 characters. Now I don't know anything, sir, but I know only 3 characters. Sir, simply it is like this. Name, like, 3 characters, right? Underscore, underscore, underscore. That's it. So what is the answer for this, sir? The same. Select star from student, where name, like, they given 3 characters, 3 underscores. If they given 5 characters, we specify 5 underscores. This is exactly, sir. So I think in this case, Ram will be displayed, Raj will be displayed, because they have only exactly 3 characters. The characters can be anything. Suppose the given name contains at least 3 characters. Sir, first of all, what is the meaning of at least 3 characters? 3 or more characters. But minimum is 3. Right? So name, like, 3 underscores. 3 are fine. The remaining string may be anything. So percentage. First 3 are mandatory. The remaining, it may be followed by any string. Even that may be null string also. So what is the answer for this, sir? Select star from student, where, sir, please observe it. I think here this time they asked only names. Sir, please observe the remaining previous examples also. I not observed it. I simply written select star. If it is only names, we need to write name, where name, like, 3 characters followed by any string. Name contains at least 3 characters. Okay. Now this is one important note, sir. SQL don't eliminate duplicates on its own. What does it mean? Suppose select age from student. Then what you expect, sir? Age is a column for which I will get the details. First record 40, second record 30, third record 40, fourth record 25, fifth record 29, sixth record 28, seventh record 77. Sir, please observe it. Here, this is a duplicate. Even that is a duplicate, it don't eliminate. It don't eliminate. If you want to eliminate, then I need to specify distinct keyword. So it will be select distinct of age. Then it will filter the duplicates from student. In this case, 40 will be displayed for only one time. 40, 30, 25, 29, 28, 77. Not only age, sir, whether it is a name or anything, whenever there are duplicates, SQL don't eliminate. It is not its duty. If we want to eliminate duplicates, we need to specify clearly the keyword distinct. The keyword distinct. The next one, order by. What is order by? Sir, we already got the information for whom I need. But after I have information, I want to sort it out. Something like I want to display with respect to name, or I want to display from younger to older people. Like that, I want to display. Answer is same, but how to display? When you are displaying, I want to sort it out. So I want to sort it by age. So we are sorting the records by age. So select all the details star from student. Any filter for records? No. Fine. Then this is the information we will get, sir. We will get generally the same table. But if you specify order by which attributes are age, right? Then what will happen is the same information age from small number to big number. What is the record with the smallest age? 25. So Sham will be displayed at first, then followed by Raj. Like that you can continue, sir. So we are displaying the result with respect to the attribute age. Order by clause is the last one, because after or once the answer is fixed, then only we specify the order in which we need to display the result. Ascending or descending. You want to sort it out, sir, that is sure. 1 minute, sir. Yeah, you are sorting fine, whether it is ascending order or descending order. Sir, if there are numbers, you are very sure what is ascending order and descending order. If there are strings, that is something like alphabetical order. So something like our dictionary orders are sorting ascending order or descending order. By default, it will be in ascending order. If you want to specify descending order, you need to use the keyword DSC. Of course, if you want, you can use, even it is default, you can specify ASC also. Something like select the records from the table student. Okay. Order by name. If you want alphabetical order from small letter to big letter, ASC. If you want descending order, you specify DSC. But whenever it is ASC, it is optional. But if it is descending order, we need to specify it. Okay. But this order by ascending or descending, all this will be attached to the query only when the overall work is done. Once the answer is fixed, then only we need to concentrate on the display. Then let us go to operations, set operations. Sir, what are the main set operations you know, sir? Union, intersection. These are the two major ones. And there is one more which is difference. We have something else also, sir, but we are not discussing, or we don't need them in SQL. So we need only these operators. When coming to union, I have two keywords, union, union all. There is a small difference between these two, sir. Let me explain with an example. Suppose I have this one, sir, staff, in which I have employee ID, employee name, gender. This is my first relation or first table. The second table is student. in which I have student ID, student name, gender. Right, sir? Now, I want all the staff names. I want all the staff names. What you write, sir? Select e-name from staff. So you get some result. I want all the student names. Select yes name from student. Okay. Suppose here I got e-name Sita Ramu. Student names we got Sita Geeta. That's it. Now what is the main difference? Whenever you apply R1 union R2, sir, simply you need to write the query of the R1 union query of R2. That is, in between you need to specify union. That's it. Then whenever you use union, what will happen is the first one, the column name will be the names of R1. So in the result we will see it is e-name only because you not given any name. So e-name. Then whenever a union, Sita is common name for students as well as staff. Whenever you apply union, if there are common elements, they will be displayed only for one time. Sita, Rama, Geeta. So whenever you apply union, common elements displayed only one time. What is the counterpart, sir? Common elements will be displayed. Let me write it here. If I apply union, common elements will be displayed twice or thrice. Depends on how many times they appear, that will be. So common elements appear multi times. What does it mean, sir? In this case, we are unioning only two tables. So Sita, Rama, again Sita, again Geeta. How many times I have Sita in the specified tables? That number of times it will be displayed. That is the main difference between union and union all. The next one, intersect. The next one is minus or except. Sir, intersect is same. Something like A intersection B. What is minus or except? Sir, their intention is same. Depending on the SQL software, it can be minus or it can be except. But the meaning is same. This is difference. Okay. Something like A minus B or B minus A. Instead of A intersection B, people will write R1 intersection R2. R1 minus R2. But instead of symbols, we use keywords. So the same tables are, suppose the first one, the same example, let us consider. I am displaying the names of employees. Select e-name from staff. intersect. That is our keyword, sir. What is the second one, sir? The second query is student names. Select student name from staff. So in this case, common records will be displayed. What are the common records for these two tables, sir? The first table heading is e-name. In the page, let us consider the same records. I think Seta is common. These are the records we considered in the previous example. Suppose I want the difference. What is the difference, sir? The same example, you can write it as a bracket, and here we write minus. So the same R1, R2. So this is R1, this is R2. What will happen for difference, sir? We know what is difference operator. Anyway, let me repeat it again. First of all, what is the result for e-name? We will get Sita, Rama. From this result, I want to delete the records of R2. What are the records you are having in R2, sir? You are having Sita in second table. So Sita will be deleted. Only Rama will be displayed. Okay. This intersect minus union we have discussed in relational algebra, relational calculus also. Okay. This is about the set operations. Fine. So let us see some previous question. Which of the following is correct? Which of the following is correct? An SQL query automatically eliminates duplicates. The second option, an SQL query will not work if there are no indexes on the relations. SQL permits attribute names to be repeated in the same relation. Can you answer this question in chat box, sir? Can you answer this question, sir? In chat box? Fine. The first one, SQL automatically eliminates duplicates. It is not true, sir. You need to specify to eliminate duplicates. The next one, SQL query will not work if there is no index. In all the previous examples, there is no index. And of course, we have not discussed anything about index. So, no relation between index and SQL query. No relation between index and SQL queries. Whether there is index or not, it doesn't matter. I can write my SQL query on my own. Right? Then SQL attribute names to be repeated in the same relation. Sir, it's not possible, sir. Suppose I have SID and I have name, I have age. Suppose instead of department name, again they are using name. Then this is not permitted, sir. This is not permitted. Why not permitted, sir? Actually, our intention is the first one is student name, the second one is department name. Suppose I have written a SQL query, select name from student. Then which column we want to display, whether the first column or the second column. There is a ambiguity, sir. There is a ambiguity. It cannot decide whether it is first name or second name. I mean second column or fourth column. So there is a ambiguity. So that's why SQL don't permit to have the same name for 2 times, 3 times. Hope you understood it. So the first, which of the following is correct, right? Which of the following is right? Yeah, the first one is not true, sir. It's not correct. SQL will not work. It will work, sir. SQL permits attribute names to be repeated. It don't permit, sir. So the first three statements are not correct. So the one and only option is D. So none of the given options or none of the given statements is correct. The next one, sir. Select operation in SQL. Select operation in SQL is equivalent to selection operation in relational algebra. Sir, selection operation in relational algebra, that is sigma of some table name. Suppose the table name is student. Okay. Now the question is, select operation in SQL is equivalent. Sir, generally in select clause, you display columns list. You display columns list. But in relational algebra sigma, we don't specify the columns list. We specify records list. Which records you want? So this is generally used to filter the records, not to filter the columns. Then to filter the columns, what you need, sir? Projection. Projection of the student. What are the columns you want? Suppose I need only name comma age. Name comma age. Those two things we specify here. So select SQL is equal to project relational algebra. Projection relational algebra. Then let us see the remaining options. So the first one is not correct, sir. The selection operation, again, it is also not correct. Third one, the projection operation in relational algebra. Yes, of course. But I think they have some extension in D. The projection operation in relational algebra. Except that SQL in SQL retains duplicates. Of course, it don't eliminate duplicates. So it retain duplicates. This is also true, sir. This is also true. But D is more strong. D is more strong. Because they have some extra conditions also. So whenever it is a MCQ, then we select D. If it is MSQ, both are correct. If it is MSQ, you can select C comma D. If it is MCQ, because fourth option is more stronger than C, I select D. Hope you understood it. Then one more question, sir. Consider a database table T containing two columns X, Y. So I have a table in which we have the columns X, Y. That is the first one. Of type integer. Both are integers. After the creation of the table, one record X equal to 1, Y equal to 1. So one record is inserted. Fine. Then let Mx, My respective maximum values. Mx is maximum of the values X, maximum of X values. My maximum of Y values. Maximum of X values, maximum of Y values. Fine. Now using Mx, My, A new record is inserted in the table 128 times. Fine. But what is the record value, sir? mx plus 1, 2my plus 1. So it will be like mx plus 1, 2my plus 1. Can you give the first inserted record, sir? What is mx up to whenever I have whenever we have only one record, what is mx value, sir? 1. What is my value? 1. So here what you insert, sir? 1 plus 1, 2. Here it will be 2 into 1 plus 1, which will be 3. Then again they continued to insert one more record. Like that they continued 128 times. Now it may be noted that each time after the insertion, the values will change. Yes, of course. Sir, whenever I insert the second record, now what is the maximum value, sir? The maximum value is 2. What is the maximum value of y? It is 3. Of course, we know. Then what will be the output of the query? Select y from the table T where x equal to 7. Hope I think we need to do the insertion for at least 7 times so that you will get the answer, right? So let us continue in next slide. Hope you understood it, right? So the initial record is 1, 1. After that, based on mx, my, we will decide it. Okay, let us see it, sir. The table name is T. The column names are xy. What is the first record? 1, 1. Whenever it is 1, 1. What is mx? What is my? Maximum of x values is 1. Maximum of y values is 1. Now the question is, I need to insert mx plus 1, 2my plus 1. Then the first record will be 2. Here it will be 3. Hope you understood it. So the table containing now 2 records. Table is xy. What are the records? 1, 1, 2, 3. Now at this particular point of time, what is mx value? What is my value? This is 2, maximum of x values. This is 3. Now again I am inserting one more record. mx plus 1, 2my plus 1. mx plus 1, sir. Okay, that is 2 plus 1, 3. 2my, that is 2 into 3 plus 1, that is 7. Hope you understood the process. Now let me write directly the values. X, y. So it's only simple mathematics. So since you understood the process, let me write it directly. mx, my. The first value is 1, 1. 1, 1. So 1, 1. So mx plus 1, 2. 2mx plus 1. Sorry, 2my plus 1, that is 3. So they will be updated 2, 3. Now this will be 3, this will be 7. Maximum value is 3, maximum value is 7. The next record, mx plus 1, 4. 2my plus 1, 2 into 7 plus 1, 15. So the values are updated 4, 15. The next value 4 plus 1, 5. 2 into 15 plus 1. Let me write it to have clarity. 2 into 15 plus 1, that is 31. So the values are updated 5, 31. Again the next value 5 plus 1, 6. 2 into 31 plus 1, which is equal to 63. So this is 6, this is 63. Then the next value is 7. 2 into 63 plus 1. Hope I think it will be 127, right? So the values are updated 7, 127. The next value is 8. It will be 2 into 127 plus 1. Hope I think it will be 254 plus 1, 255. Like that they will continue for 128 times. But please observe the query, sir. Select Y. I want to select the value Y. Do you need all the Y's? No, sir. I want only the record for which X equal to 7. So that means I need only this particular record. What is that particular record, sir? 7, 127. In this, what is Y value? 127. So we will get 127. Hope you understood it. Yeah, that is for today's session, sir. In next session, we will discuss, or we will mainly concentrate on what is group by, how to use it, and how to deal with null values. Whenever we are having null values in the relation, how to deal with them. Okay. So with this, we completed today's session. Thank you.